2. Today we're going to um, learn how to simplify radicals. So here are the parts of a radical. This little part right here in the notch is called the index. This big check mark part is called the radical sign. The number under the radical is called the radicand. So this is a radical sign. When I look down here at this, I would read that as the square root of 16. So you notice that on all of them, we don't have a little number in the notch. So when there's no number in the notch, that means the index is 2 because I just read that as the square root of 16. All right, so we're going to teach you how to solve these, or simplify them rather, by perfect squares. So perfect squares is when you take a number and you square it. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And then I would have 16, 25, 36, 49, 64, 81, 100, 121, and 144. So all of these are the first 12 perfect squares. So you know that it's a perfect square because it's the answer to some number squared, etc. All right, so we have the square root of 16. A lot of you just simply know that that is 4. We have 2 times the square root of 121. So when there's no sign in between the 2 and the radical, you have to know that that is multiplication happening. I'm going to take the square root of 121 and get 11. So this is also multiplication. So I'm going to multiply and get my good final answer of 22. The square root of 289. I don't know what that one is. So on my calculator, I look above my x squared and I see the square root button. So I'm going to hit second and that and put in 289, and that is 17. So I have 6 times 17 equals 102. I put the square root of 400 in my calculator, and that is 20. 3 times 20 equals 60. So those were perfect square roots. The next section, they are not going to be perfect squares, but we have the steps to follow. We are going to look for the largest perfect square that's a factor of the number under the radical symbol. When you take the square root of a number under the radical, its answer comes out from under the radical. And then you'll probably have a leftover piece, and the leftover stays under the radical. All right, so we are going to only divide by these numbers. So 32 divided by 4 is 8. I'm going to see if I can go bigger. 9, nope, that isn't going to work. 16, that might work. I went 32 divided by 16. That equals 2. Maybe some of you remember making tractor trees like back in, I don't know, 5th, 6th grade. So that's basically what I'm doing here. I'm taking 32 and I'm breaking it down into factors that include a perfect square. So I chose 16 because the square root of 16 is 4. So that comes out from under the radical. This 2, I can't take the square root. It's my leftover piece. And so that is your good final answer on that one. 180. So sometimes you just have to start dividing and see which one works. So I went 180 divided by 4. That one worked. I'm going to see if I can go bigger. 180 divided by 9. That one worked. Okay, let's see if I can go bigger. 180 divided by 16. Nope, I get a decimal. 180 divided by 25. I'm going to skip that one. I mean, that one's not going to work. Divided by 36 is 5. So I'm looking for the biggest one. So 36 times 5. 36 is a perfect square. The square root of 36 is 6. It comes out from under radical 5. And that is how I did the rest of the page. Let's see, I'm going to jump down and do this number 10. All right, so if you have a number out in front, you're going to, we'll deal with that and multiply it later. 54, I broke that one down into the product of 9 and 6. So this is a multiplication problem. The square root of 9 is 3. So when that comes out from under, it's just a regular 3. And now I have something to multiply together. I can't do anything with the 6, so I leave it alone. I'm going to multiply that, and I get 6 radical 6. Next side, we are introducing the concept of imaginary numbers. So imaginary numbers are not real. They fit into a category of numbers called complex numbers. So we have this lowercase I. So the abbreviation for imaginary numbers is I. If you would like to solve for I, I'm going to take the square root of both sides. So radicals and exponents cancel each other out. I can't take the square root of a negative number. So I, by definition, is the square root of -1. Some examples of imaginary numbers. You might have a 3i. It could be a negative coefficient. A complex number has a real part and an imaginary part. It could be 5i radical 2. We could have a coefficient and a radical part of it. All of these are examples. I'm going to simplify the square root of -81. So anytime you have a negative number, like maybe back in algebra 1, if you put in the square root of -81, you get domain error. So you are allowed to say no solution. In algebra 2, you're not allowed to say no solution anymore. So I'm going to rewrite this the product of -1 and 81. I can take the square root of each of these. The square root of -1 is I, by definition, above, and the square root of 81 is 9. So when you take each of these out, they're multiplied together, and we put numbers before variables and our good final answer. I'm going to move down and do the square root of -18. So anytime that you're negative, factor out a -1 there. 18, I know, breaks down into 9 times 2. The square root of -1 is I, by definition above. The square root of 9 is 3. Can't do anything with the 2, so it stays under the radical. Then I'm going to fix this order, and it's 3i radical 2. We're going to simplify 3 radical negative 28. Deal with that 3 later. 28 factors as negative 1. 4 times 7, because 4 is a perfect square. So I keep my 3. The square root of negative 1 is I. The square root of 4 is 2. And I can't do anything with the 7, so it stays. I'm going to multiply these numbers together, and my good answer is 6i radical 7. And that's how you simplify radicals.